To load black powder cartridges, you need the case, powder, and bullet. Optional is a lube behind the bullet, but if you're using that, you need a wad on either side so that it doesn't mix with the powder or get stuck on the back of the bullet. A wad is a simple disc of material. Anything can be used. Something thick like felt or cardboard will take up room, allowing for a smaller powder charge, or something thin like these cardboard wads to increase the powder charge. These are what I use most often. I've been punching them out using these, a cheap set of hole punches. The best way to use them I've learned is in the arbor press. But any way that you use them, they're a pain. They're slow, and the resulting wads don't look the best. The ends are ragged, and they usually come out domed, not flat. But the biggest issue with these hole punches is that they only come in a few sizes. Most often I'll use the 3/8 for 9mm pinfire, 7/16 for any .45 caliber, and 1/2 inch for .50 caliber. But none of those are perfect since they come out undersized. This .50 caliber wad actually measures .485. That's because they're meant to punch a hole, not to make a wad. There has to be a better way. That's when I made this. It's a wad punch that mounts in a reloading press. This isn't my invention. I've seen this design before, though from what I've seen, these aren't commercially available. It works like this, with the wad punch die fully screwed down in the press. The separate punch piece is inserted into the ram in the place of the shell holder. Then it's raised until the punch enters the die, which takes some alignment. With the ram all the way up, you can see the cutting edge here, just down within the die body. As I lower the ram, it exposes this slot where the material is inserted. The cutting edge of the punch, pushing the material against the upper edge of the slot, is what cuts the wad. I'll demonstrate just how fast I can cut simple cardboard wads. These are very cleanly cut and perfectly flat. The thickness of the slot allows it to cut thicker materials as well, such as corrugated cardboard. And this cork sheet. The major downside, though, is that a die and ram can only cut one size of wad. I made this for .45 caliber. These are coming out .454, which is right around the size of a 45-70 case mouth before the bullet is seated. If I want a different size, I need a whole new die and ram. But after seeing how well this works, it's worth the effort to make another. My next most often used size is .50 caliber. The punch will be easy to make with this piece of 1/2 inch 4130 steel rod. The die body I'll make from this scrap piece of mystery steel. I'll get it chucked into the lathe and drill out the center hole. The through hole I drilled is actually 31/64. That's because I'll finish the hole with this 1/2-inch reamer. The resulting hole will be much more accurate than I can get with a drill bit, and it will have a much better surface finish. This piece that will become the punch is a good fit within. Now to get the outside of the wad punch die to shape. With the outside shaped where I want it, it's time to cut the threads. It's a pain to set up my lathe to single point cut. I'd have to add the compound back on. Plus large threads always give me trouble on the small lathe. Instead, I'll cut them using a die. I cut the outside diameter a bit small so that the die would have an easier time cutting the threads, but it was still very difficult. I'll test fit it in the reloading press. It threads in easily. When it's bottomed out, I'll mark the front. This is where I'll want to cut the slot so that the material can be inserted from the front. Then I'll get this over to the mill. To cut out the slot, ideally I'd use some type of slitting saw, but I don't have one as thick as I'd want to make it, say an 1/8 inch. Therefore, I'll turn it over so that I can cut the slot by plunging down. I'll use this 1/4 inch end mill. Having the shank the same diameter as the cutting edges will allow this to cut the full depth of the slot. That last pass was to clean up this surface here, since that will be the surface the punch is pressed against to cut the wad. You can see the depth at which I cut it to, just past the central hole. This allows it to punch a full circle wad, while also retaining enough material for strength. I'll get this deburred. I would be completing the punch piece next, however I ran into an issue. The lathe looks like this. This is where the motor would be, but instead it's over here. This project started with the lathe sounding like this. When finishing the turning on the punch body, it sounded like this. A little higher pitched. Now it sounds like this. I think that one of the shaft bearings is loose in the housing, which is sometimes an issue on cheap Chinese-made motors like this. I got a replacement motor. I'll get it installed. That was not as straightforward of a swap as it seemed, but modifying the lathe to fit the new motor is not the topic of this video. Back to the hole punch. This piece of 4130 is already a ½ inch in diameter, so I only need to machine the ends. I'll get this side faced, and then a notch cut so that it will fit into the ram of the press. The other end I'll make into the sharp cutting edge of the punch. When making a sharp edge like this, there's inevitably a burr created. I'm not going to worry about that. It should break off on its own once this is first used. I chose to use 4130 steel for this piece because of its durability, but also because it can be hardened. That will make the cutting edge last longer. I don't have a heat treating oven. Instead, I'll do this by eye with a torch. Turning off the lights helps to see the color change. I'll hold it at a dull red for a bit before quenching in oil. The steel is now very hard, but also very brittle. To replace some brittleness with toughness, I'll temper it in the oven. I'll set it to 450 degrees and leave it for about an hour. While I wait on the punch, I'll add a few finishing touches to the die body. To mount it in the truck, I'll use this piece I made a while ago. It has 7/8 14 threads on the inside and a slot cut down one side. This allows me to hold onto the threads without damaging them. I'm sanding instead of cutting the outside because I don't want to reduce the diameter any and potentially lose any strength. I'm just getting this surface prepared for finish. Then I'll lightly paste the top to clean it up. Now that the machining is done, I'll finish the portion of the die body that sticks up out of the press. This jar of cold blue has seen better days, but it still works for shop projects like this. I already have the die degreased and lightly preheated. I'll dunk it in. Cold water neutralizes the cold blue chemicals. Then a quick rub with steel wool. And finally a light coating of oil completes the finishing. Actually, there is one final thing that needs to be done. A quick marking will let me be able to tell one from the other at a glance. With the die body finished, so is the punch. I just clean this up with a bit of steel wool. Now I can test them out. I'll screw the die body down all the way into the press. The slot is aligned towards the front. Then I'll insert the punch in the place of a shell holder. The generous chamfer at the bottom of the die helps to align the punch. At the top of the stroke, the cutting edge of the punch is just below flush. And just like with the other die, there's a slot for the material exposed. Let's see how well it works. The wad measures just under a ½ inch. Perhaps I'm squeezing the wad with the calipers a bit. This dedicated wad punch is a big improvement over my previous process. I can really crank out a large number of wads quickly. Though like I said earlier, the downside is that each punch will only make one size. But now that I have these two, these cover a few different calibers, since the 4.54 punch will also work for the 4.46 bullets used in 11mm Mauser. and it really isn't very hard to make another if I need to. Thanks for watching.